Hello, welcome to today's lecture. Today we are going to understand a very important concept in Python, and this concept is very important, and the concept is of decorators. Okay, so decorators are things that can create a wrapper around functions and classes. Okay, this decorator can wrap a class or a function, and through that wrapper it can modify its behavior. Okay, it can modify its behavior through that wrapper but without touching its source code. So it's a very powerful feature or a very powerful concept in Python. Okay, so let us see how it works. Okay, so let us define a function Fibonacci. Okay, we are creating this function so that we can get the Fibonacci of a certain number. Okay, so this would return Fibonacci fib of num minus 1 plus fib of num minus 2. Okay, so this is through recursion. Okay, so we are going to use recursion here. Okay, this video is not about recursion, so don't worry if you are not getting it. Just focus on the decorator part and follow along with me and copy and paste the code. So fib of a number, and we are returning the result here. Okay, so it also needs base case. So if number less than equals to 0, we are going to return 0. Okay, and if elif number is equals to 1, we are going to return 1. So turn 1. Okay, so this is the function. So this will calculate the Fibonacci. Okay, so print, and we are going to provide it a number. Okay, so let us print this. Print Fibonacci of number 7. So if this works correctly, we would get a result of 13. Okay, as Fibonacci of 7 is 13. Okay, so as you can see, the result is 13. Okay, so it's working correctly. And now we are going to, okay, so let us print Fibonacci of suppose 300. Okay, so as you can see, when we type Fibonacci of 300, it's taking a lot of time. Okay, so it's taking a lot of time and we can't get the result here. Okay, so it's taking a lot of time. So this function, as it uses recursion, is getting extremely slow with large numbers. Okay, and 300 is not a very large number, but still it's slow, and you can see that it is still calculating the result. Okay, and it would take a lot of time. So let us now improve this function using decorators. Okay, let us now improve this function using decorators. So what we are going to do is that we are going to store the values that we get from these computations. Okay, so we are going to store the values that are needed to compute further values. Okay, as in the case of Fibonacci, we need the sum of previous two numbers to calculate the Fibonacci of the number. Okay, so Fibonacci, if you want to calculate the Fibonacci of number 6, so you have to make the sum of Fibonacci of number 5 and Fibonacci of number 4. That would be equal to the Fibonacci of number 6. Okay, so it works like that. So if we can store values or data related to the previous numbers, okay, related to the output of the previous numbers, okay, then we can make this function very fast. Okay, so this concept is known as a memoization. Okay, so let us define a decorator function. Okay, and this decorator function will wrap this function and we are going to implement certain things in that decorator function that would store the values related to the data that this function generates. Okay, so let us create a decorator here. So fifth decorator, I am going to name it like this. Okay, and this takes a function. Okay, this takes a function, and we are going to define a wrapper in here, and this contains these are the arguments that we are going to pass in the function. Okay, and we are going to create a cache variable. Okay, so whenever this Fibonacci function would return data to us, we are going to store that in a cache. So suppose if we use Fibonacci of 3, if we call it with Fibonacci of 3, okay, then this would return data related to Fibonacci of 0, Fibonacci of 1 and Fibonacci of 2. So we are going to store all this data into the cache. Okay, so when someone calls again, suppose someone calls this function with a number of 6, we already would have the related data in the cache. Okay, so you would understand as we progress in this. Okay, so now let us create a result variable and have this function here, and we have to pass the arguments here. Okay, so args and args. Okay, then we are going to return the result, and we are going to return the wrapper. Okay, so this is how we wrap a function. Now, so we are going to type if args in cache. So if the argument is in cache, okay, then we are going to return cache then arguments. Okay, so this would return the value. Else what we are going to do? We are going to add this result to the cache. Okay, so cache and then args. We are going to insert this result to the cache. Okay, we are going to create a key with that related argument in the cache, and we are going to make it equal to the value of result. Okay, so now let us print entering cache, so that we know that this result is coming from the cache. Okay, and we are also going to print cache here. So that we know what we are storing in the cache. Okay, and we are going to print entering normal. Okay, so if this code runs, we are going to see entering normal, and if the result comes from the cache, we are going to see entering cache. Okay, so now as we have created this decorator, we can use the special syntax. We can use add and then the name of the decorator. Okay, so this is the name of the decorator, and we have decorated this function successfully. And now let us print the Fibonacci of 7. Okay, let us see what happens. Okay, so as you can see, this is how it works. Okay, so it's a storing. This is 1. Okay, and this is 0. This is 2. So this is like Fibonacci, it's storing the value of Fibonacci 1, Fibonacci of 0, Fibonacci of 2, and then you can see it stores the value up to the Fibonacci of 6 in it. Okay, so it computes this result very fast. Okay, so let us check whether Fibonacci of 20. Okay, let us check Fibonacci of 20. So as you can see, it stores the result in a cache up to 19 here. Okay, so the motto of the video was to explain the decorators. Okay, and as you can see, we haven't touched the code inside this function. We just use the decorator to create a cache like structure that is storing our values. Okay, that is storing the values that this Fibonacci is generating. Okay, this Fibonacci function is generating. So this is how a decorator wraps around a function, and it modifies or extends the capability of an existing function or a class. Okay, so this is how decorator works. There are more ways to do the same thing, and there are some more unique ways, and I'm going to cover all of them. Okay, so let us now, previously the Fibonacci of 300 was taking a lot of time. Okay, let us now check it whether this is making that faster or not. Okay, so we are going to so as you can see Fibonacci of 300, it is now calculated very fast. Okay, so it's now working very fast. Why it's working very fast? Because Fibonacci of 300 is composed of the data that this function generated many times. Okay, so Fibonacci of 300 would contain Fibonacci of several other numbers, and if you have the data related to if you have the result related to that all other numbers, you have to just calculate some things. Okay, and all the results that you have in your cache, you would use that to calculate this value. So this is how memoization works. Okay, and this makes the code faster.